Hey everybody, this is our final section of Unit G. This is G-8, where I can name coordinates of special figures. We're going to take shapes, these quadrilaterals, we're going to set them on a coordinate plane. And then we're going to identify coordinates of vertices. So as you look here, you see we have a shape. We're calling it a square. We're saying that SQ is 2A. The question is, what would be the coordinates of each of these vertices? You can't give them a number because it's not a specific square. We want to be able to use this for any square. So we're placing this so that 0, 0 is smack dab in the middle. Since SQ, this length is 2A, it makes sense that this side is just A. This side would also go A units. This would go up A units and down A units. So if I wanted to go to this point, I would start at 0, 0 here. I'd go A to the right, and I'd go up A. So this coordinate would just be A, comma, A, whatever that A value was. If A was 3, it would be 3, comma, 3. What would happen down here? We would again start at 0, 0. We'd go over A, so my A would be there. But this time I'd go down A units. So this would be negative A, because I'm going in a negative direction. Over here, we start at 0, 0. We're going to go this direction, which is negative, so negative A, and then positive A. So negative A would be my x-coordinate, positive A would be my y-coordinate. And over here, I have to go negative twice. I got to go negative to the left and negative down, both negative A's there. So that would be how I would name the coordinates or something like that. All right, you can't just name them A, B, C, D, whatever, because they're related to each other. So in this case, they're all A's. Over here, we have a triangle, and we're saying that the y-axis is a median line, so this is the midpoint of this side, and it says TI is 2A. So that means this side is A, and this side is A as well. So the coordinate of this point would be over A, but we're not going up and down at all, so that would be 0. A0 would be right there. This coordinate, we're going to go left A, so that's negative A, and we're not going up and down at all, so the y-coordinate is 0. And then this one, I don't really know all of it, but I do know that the first coordinate is 0 because we're not going left and right at all. All we're going to do is go up to that point. So the x-coordinate is 0, but this length is not related to the base at all. So I don't know what that is. So that can be, now we're going to introduce a second variable. We'll just call it B. So that one, since it's not related to A, we just make up another variable. We'll call it B. Let's look at the next one. The diagonals of the parallelogram intersect at point D. What are the coordinates of D? Well, we know that in a parallelogram, this is the midpoint of both diagonals. So we're simply going to use the midpoint formula and find out what the coordinates of D are. I don't have to do both of them. I can just do one of them. So let's just pick one of them. Let's pick this one. So this one, we're just simply going to take and add the two coordinates. We use the midpoint formula. So it looks like this. We take the two x-coordinates, 2A plus 2B, and we divide it by 2. Because the midpoint formula is back here from our notes. The x-coordinates added together, divided by 2. Then we'll do the same thing with the y-coordinates added together, divided by 2. So those are the two x-coordinates added together, 2A and 2B. The next one will be 0 and 2C. I'll put 2C first, because it doesn't really matter. And now we simplify that. Well, we can divide out the 2. So we're simply going to get A plus B, comma, and then this is just going to be C. And so that's going to be the midpoint where they intersect point D. And last but not least here, we're going to look at this particular shape. This is a trapezoid. We want to show that MN, which is here, is parallel to RA. So we want to show that the slopes are both the same. So let's check the slope of Well, I guess we first have to know what the coordinate of M and N are. So that means we got to use the midpoint formula like we did up here. So M would be 2b plus 0 over 2, comma, 2c plus 0 over 2, which would simply be b, comma, c. Right? That's going to be 2c over 2, 2b over 2. N is going to be 2a plus 2d over 2, and 2c plus 0 over 2. That's going to give me a plus d, comma, again, c. All right, so those are the coordinates of this. Now I want to find the slope of this line. So that means I'll do rise over run. I'm going to use the slope formula. So the slope formula basically says m will equal y2 minus y1 over x2 minus x1. So y2 would be c minus, it doesn't matter, c minus c. And then we're going to do x2 minus x1. So let's use a plus b first. Minus b. That's going to be 0 over a, which equals 0. So I know that the slope of this line is 0. Let's find the slope of RA. So we'll again use our y2 minus y1, 2c minus 2c, over 2b minus 2d. So I'm subtracting the x values here and the y values here. That's 0 over 2b minus 2d. It doesn't matter what the denominator is. We still have a slope of 0. And since both of those are 0, we can say definitely we are parallel lines because the slopes are the same. And there's our look at our notes and our examples for our final section of Unit G, G8.